So you're going to take a look at arcs and chords and relationships between different pieces of chords, but also measures of angles and arcs and degrees and how those go together. In a plane, an angle whose vertex is the center of a circle is the central angle of a circle. If the measure of angle ACB is less than 180 degrees, then AB and all points on circle C that lie in the interior of angle ACB form a minor arc. So minor arcs are less than 180 degrees. Points AB and all points on circle C that do not lie on arc AB form a major arc. So major arcs are greater than 180, minor arcs are less than 180, and a measure of a minor arc is a measure of its central angle. Okay, we'll pause the presentation at this point so that the students have an opportunity to copy down these definitions. The measure of a major arc is a difference of 360 degrees and a measure of its related minor arc. A semicircle is an arc whose central angle measures 180 degrees exactly. So a minor arc is less than 180, major arc is greater than 180, and a semicircle is 180 degrees exactly. And then we also have the arc addition postulate, and it just simply states that the measure of an arc formed by two adjacent arcs is the sum of the measures of the arcs. So we can add arc measures together just like we can angles and segments. And again, at this point, we'll go ahead and pause the presentation in order to let the students copy down the definitions. Okay, a couple theorems here. Theorem 10.4 says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. And we'll take a look at how that applies here in a little bit. There used to be a 10.5 and a 10.6, but we converted that into a biconditional statement. And it states that a diameter of a circle is a perpendicular bisector of a chord if and only if it's perpendicular to the chord. Okay, so diameters are perpendicular bisectors of a chord if they are perpendicular. And theorem 10.7 says in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, again, we'll pause the presentation at this point in order to allow the students to copy the definitions. Okay, the next picture takes a look at a couple of the properties with the perpendicular bisector theorem of the chord. And because you have a chord that is perpendicular to a diameter, we know that the chord is going to bisect the diameter. So each of these pieces here and here are going to be equal. So the question asks us to find a length from h to k. Well, if n to k is 7, h to m has to be 7 as well, and that means that our length from h to k needs to be 14. Now, we also need to find a measure of h to k over here. Okay, so this big green piece. Okay, so that diameter is going to bisect the chord. It's also going to bisect the arc that the chord cuts off. So that means that those two pieces over here of 11x and 70 plus x are going to be equal. So we let those equal each other. We'll subtract our x from both sides, which means that 10x is 70. And then from there, that means that x has to be 7. Now, we need to plug those in. Well, if hj is 11 times 7, that means that hj is 77, as is jk. When I add those two arcs together, the measure of my arc from h to k has to be 154 degrees. And again, we know that's a minor arc because it is less than 180 degrees. Okay, and that's a big key. Okay, your minor arcs are less than 180, the major arcs are greater. Okay, in our diagram that we have here, in exercises 1 and 2, we want to use our diagram of circle D. If our arc from A to B is 110 here, and BC is 110, because these two chords here cut off our arc. Okay, so that's going to be 110. Now, what if arc AC is 150 degrees? And I want to find the measure of arc AB over here. Well, you know again that the two arcs have to be the same from A to B and B to C. So I'm going to take 360 and I'm going to subtract 150 from that. And that's going to give me 210. I'll divide that by 2, and then both arcs A and B, as well as arc B and C, are 105. Okay, at the bottom, what is our length from C to E? Okay, it's going to be 10. Because if C to F is 5, And CDE has to be 10 because that chord bisects as a perpendicular to our diameter, and as a result, the diameter bisects the chord. What about arc CE? Well, we know that with this problem here, that these two pieces of 9x and 80 minus x have to be the same. So we're going to let them equal each other. We're going to add x to both sides. So 10x is 80. That means that x is 8. Now, we need to find the measure of arc CD first. So I'm going to take 9 times 8, which is 72. But my arc down here is 72 as well. So the measure of arc CE is 144. Okay, here's another example. We have two chords from A to B and D to E that are both the same. That means that our two arcs out here from A to B and D to E are equal also. So x plus 6 equals 2x minus 3. Subtract our x from both sides, add our 3 back to the other side at the same time, and we find out that our value of x is 9. Okay, this time we have a diameter that's perpendicular to a chord, and as a result of that, we know it bisects the chord. So those two chord pieces of 3x plus 1 and x plus 9 are equal. So we're going to subtract x from both sides. Also subtract 1 at the same time. So 2x is 8. That means that x is 4. And on our last one, like this, we want to determine whether LP is the diameter of circle C. We're going to explain our reasoning. Now, we see that LP bisects KM. But what else do we need to have? Okay, we also need to make sure that LP is perpendicular to KM. And since it's not, we know that our answer is no, because segment LP is not perpendicular to segment KM. In order for that to be a diameter, it has to bisect the chord, but it also has to be perpendicular as well. Okay. All right, the other big key piece from today is we're taking a look at whether we have major arcs, minor arcs, semicircles, or also degree measures for our arcs. Okay, now when our angle lies at the center of a circle, okay, there's going to be something very specific that happens here. Here's my angle from S to P to R. That cuts off arc RS over here. So what is the measure of arc RS? Well, the measure of your central angle is equal to the measure of the angle on the other side. So this is going to be 110 degrees. Okay, so if my angle is 110, my arc is 110 also. The other thing that you need to know is if you have two letters, that guarantees you a minor arc. Okay? If you have three letters in your name of your arc, okay, it is a major arc or a semicircle, which means that if you have three letters in a name, you know automatically that your angle of the arc has, or the degree measure of the arc has to be bigger than 180, or it could be 180 itself. If there are only two letters, you know that the arc has to be less than 180 degrees. So my next problem asks us to find a measure of arc RTS. So I start at R, I'm coming around to T through S. Okay, so I have a major arc because that's bigger than my semicircle. Okay, so what I need to do for this one is I need to take 360 and subtract 110. And that tells me that the measure of my arc will be 250 degrees. Okay. On our last one, we're going to start at R, we're going to come through S and stop at T. Now, keep in mind that P to, or R to T is a diameter. So what does that tell us about our degree measure of our arc from RS to T? Okay, it's a semicircle, so that's going to be 180 degrees. Your minor arcs are equal to the measure of the angles at the center of the circle, okay, which is called the central angle. Okay, here's another example. We want to determine whether we have a arc as a minor arc or a major arc. Okay, so what about PLM? Okay, if you take a look at PLM, it kind of looks like it is a semicircle, but if you were to add those two arc measures together, you'll notice that 142 plus 40 is 182, and as a result, that is a major arc. What about number 2, NL? Okay, we know right off the bat that's a minor arc. because those only 2 letters in that name, and if it's only got 2 letters in the name, we know we have a minor arc. All right, so our next series of questions asks us to find the measures of our arcs. Okay, and the first arc it asks us to do is to find LN. Okay, so here's L to N, and those are 2 arcs combined. Now remember, we can add our arc measures together, and as a result, we're going to take 40 plus 38, and that's going to give me 78. Okay. Question number 4, the arc from P to L to N. Okay, well this time we have to add all 3 arcs together over here. So that's going to be 142, 38, and 40. And if I add those together, the measure of the arc from P to L to N is 220 degrees. Now, that becomes significant because our other piece that we need to find yet is the measure of our arc along the edge here from P to N. Okay? Well, that arc has a degree measure of 5x. So what we're going to do is we're going to take 5x, and that has to equal 360 degrees minus our big blue arc. Okay, so if I take 360 and minus the big blue arc, which is 220, that gives me 140 degrees. And that is what 5x equals. So we're going to divide both sides by 5. And when we do that, we find out that x is 28. Okay, are there any questions on those? Okay, this is another picture. Looks very, very similar. Okay, this time we want to find a measure of arc BC. The measure of arc BC should be what? Okay, it's going to be 55. Okay, because the measure of the central angle equals the arc. Okay, our next one, the arc from A to C. Okay, well those 2 arcs are 75 and 55. And they're going to combine to 130. What is the measure of angle BED? Okay, that's going to be 95 degrees. And the last question asks us to find the length from C to D. Now, this goes into what we did in the last lesson. And in that last lesson, we found out that we took 40 degrees, the measure of our central angle over top of 360, and we multiplied it by 2 pi times our radius, which was our circumference of the circle. So what we ended up doing was getting a portion of the circle multiplied by the circumference. Now, 40 over 360 is going to simplify. 4 cancels down to 1. 36 cancels down to 9. So I have 1/9 times 6 pi. Remember that 6 pi is over top of 1. Both of these numbers are divisible by 3, so it becomes 2 pi, and this becomes 3. And we end up with 2 pi over 3 for our arc length. Now, so you can do that also on the calculator. Remember using the Math 1 key in order to simplify your fractions, and that will work out just as well. Okay, we want to find a measure of each of our arcs. On our first one, we're looking at arc GE. Okay, GE is a minor arc because we know that the number is less than 2, or it's only got 2 letters in it. So here's the arc from G to E. Okay, so we're going to add those 2 numbers together, and 40 plus 80 gives me 120. Our next example starts at G, comes around to E, and works back all the way to F. Okay, so we're going to add those 3 arcs together. 40 and 80 was 120. So we add 110 onto that, and GEF should be what? Okay, 230. Now, the last question asks us to find the length of the minor arc from G to F. So that's this one here in the dark red. Okay, well, if the other 3 arcs add up to 230 degrees, GF needs to be what? Okay, 130. Are there any questions on those? A recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. We want to find our indicated arc measures. What about our arc from A to C? Now, remember this is a minor arc, so I'm starting here at A and coming around to C on the smaller side. So I need to take those numbers for a musician and an inventor and do what? Okay, we need to add those together. That's going to give us 137 degrees. Okay, what about the measure of arc ACD? Okay, so I start at A, I'm going to crank around through C and back over to D. Okay, well I've got 137 degrees already for AC. Now I need to add those 83 degrees onto that as well. Okay, and if I do that, that comes out to be what? Okay, 220 degrees. Okay, on our next one, we have the measure of arc ADC. Okay, so here's A. We're going to crank around to C, going through D. Okay, so we're going to add 79, 61, and 83 together. And what do we get for that one? Okay, 223. And then for the last one, we start at E. We're going to roll around all the way back to D over here. Now, you have almost the entire circle except that little mint colored others, which is 61 degrees. So we're going to take 360 and subtract that 61 away. That's going to give us 299. Okay, any questions on that? Okay, the last example that we've got, you see this picture here. You have a 4x minus 5 on the left and an x on the right. What you need to make sure that you're aware of is that this x, remember, is the measure of your central angle, so that's also the degree measure of your arc. And where kids get tripped up on this is there's no real numbers here to figure out. But what do we know about the degree measures in a circle? Okay, they add up to 360. So I'm going to take that 4x minus 5, I'm going to add x to it, and that's going to give me 360 degrees. So that's going to be 5x minus 5 equaling 360. We'll add our 5 to the other side, so 5x is 365. And then we're going to divide both sides by 5. And when we do that, x is 73. If it seems like there's not enough information in a problem, the one thing that you do need to make sure that you remember is that the angle measures in an arc do add up to 360. Okay, at this point, we'll go ahead and stop the presentation, and we'll pass out the homework tonight, which is section 9.3 worksheet.